Welcome back, Year 5. In today's math lesson, we're going to continue our work on problem solving with decimals. We have two learning intentions today. The first is to solve more complex addition and subtraction multi-step problems. Our second is to identify and interpret the information necessary to solve the problem. All that second one means is that when we read a problem, we can figure out what it needs for us to do and what information we'll need in order to do it. Let's start though with a little warm-up. We're going to be comparing some decimal numbers. So as I said, we're starting with a warm-up, and that warm-up is to compare decimal numbers. The reason we're doing this is because if we can compare decimal numbers successfully, that means that we really understand the values of these numbers. So let's start by looking at a place value chart. We have the ones over to the left, then after the decimal point, we have the tenths place, the hundredths place, and the thousandths place. So when I write the number 2.36, the 2 would go in the ones place, then we have our decimal point, 3/10ths, and 6/100ths. If I were to compare it now to the number 2.35, again I have 2 in the ones place, which means it's exactly the same. I have 3 in the tenths place, so again, still the same. And then I have a 5 in the hundredths place, so this is where the difference is. When we start comparing numbers, we always start at the left. We start at the biggest value, which in this case is the ones place. So it was the same. They both have two wholes. They both have 3/10ths, so we're forced to compare the hundredths place. This is where the difference is, and clearly 6 is bigger. So in this case, 2.36 is greater than 2.35. What about here? Let's compare 9.85 to 9.82. You'll notice that I'm taking the exact same numbers that you would be seeing on the left-hand side of your screen. Again, when I look at these numbers, I start at the left, so I start at the greatest place, which is the ones place, and they both have 9. After the decimal point in the tenths place, they both have 8. So far they're the same. The difference is in the hundredths place. So clearly, 9.85 is larger. So far these have been pretty simple. But what about when the places are shuffled around a little bit? Let's say we have 0.47 compared to 0.047. Now, you might be tricked because you see 47 in both of these numbers. But you have to look at their places because the place determines the value of the digit. Let's start at the ones place. Let's always start at the greatest place. They both have 0 ones, so they're the same in that regard. But when I go behind the decimal point, this number has 4/10ths and this one has 0/10ths. Notice the 4 is in the hundredths place, and if we go back to our place value chart, we see tenths are greater than hundredths because as you move to the left, things get bigger, 10 times bigger. So that means because the 4 appeared before it did over here it's in the tenths place and here it's in the hundredths, this number is bigger. It shows even more when I stack them on top of each other. So here's 0.47 and here is 0.047. This 4 came first, so that means this number is larger. Let's do another one. 1.75 compared to 1.7. All right, well, you might think this one is bigger just because it has 3 digits, but that's not really the reason. Because remember, 1.7 is the same as having 1.70. I can put as many zeros behind this as I want and it doesn't change the value. It's still 1 7/10. This is 1 7/10 and 5/100, or 75/100. The reason this is larger is because it has something in the hundredths place and this one does not. So 5 is greater than 0. So far all my signs are facing this way. Interesting. Let's just do one last one. 3.55 compared to 0.355. Again, you might look at this and say, hey, They have the same numbers, 355, 355, if you ignore the decimal point. Of course, that's not what these numbers really say. It's not 355. But if you pay closer attention to the place value, ones place, tenths place, tenths place, hundredths place, and this goes to the thousands place, you'll realize that one of them must be bigger because they're not in the same places. This number has 3 ones and this one has 0 ones. So which is bigger, having 0 or 3? Well, 3, of course. So this number is greater. Now on the left-hand side of your screen, you would have seen all the problems that I've just done, these 5. But there are others. I want you to complete the warm-up by comparing the rest of those numbers. Now for our Discover portion from the textbook. What I really love about the problems today is that they are multi-step. So they're a lot more interesting. You got to do a couple things before you can really get to the answer. So it kind of requires you to be a bit of a detective. In our picture today, we see Ebo and Emma, and it looks like they're in the kitchen weighing some things. I see the oats on the scale, and it looks like those oats weigh 2.6 kilograms. I worked that out by just checking the number of steps in between the 2 kilograms and the 3 kilograms, and I realized that is on the 6th step, so it would be 2.6. The pears weigh 0.89 kilograms. And I see Emma has some sugar and oats over to the side. Ebo's about to put some sugar onto the scale, and that sugar weighs 3 kilograms. But on the other side of the balancing scale, there's some oats and some pears. So let's see what the question is. What will happen to the balance scale when Ebo puts the bag of sugar in the empty balance pan? Okay. Oh, so it wants me to figure out, is the scale going to be balanced or is one side going to tip down and the other up? Well, to figure that out, because I already know that the sugar, let me make a little note, the sugar he is holding weighs 3 kilograms. So I need to figure out the oats and the pears, do they weigh more or less than that? For me to work that out, I have to add them up. So remember I said the oats weigh 2.6 kilograms, and I worked that out by looking at the scale. So let me do a little note for the oats. That's 2.6 kilograms. And then the pears, it tells us right on that digital scale that they weigh 0.89 kilograms. So I need to work out the total, so I'm going to add them up. All right, so since I know, I've been practicing this a lot, that when there is nothing above a place and it's after the decimal point, I can just fill it with a 0. I'm going to go ahead and just add because I don't want to squeeze in a 0 there and make this look confusing. So nothing plus 9 is 9. 6 plus 8 is 14. Sorry, my hand is shaking so much. 1 plus 2 is 3. So together the oats and pears weigh 3.49 kilograms. And now I have to compare that to 3 kilograms. Well, 3.49 compared to 3. Remember, 3, that means 3 wholes and nothing in the tenths place, nothing in the hundredths place, nothing after that. So they both have the 3 in common, but this has tenths and hundredths, so that would be greater. So this tells me then that when he puts that sugar into the balancing pan, the side with the oats and the pears is going to stay lower because the sugar is lighter. So the balancing scale is not going to be balanced. It's going to be weighed down on the side with the oats and the pears. So I'm just going to pause this and then write my sentence and show you what I wrote. All right, so this is what I wrote. The scale will tip to the side with the pears and oats because they weigh 0.49 kilograms more than the sugar. And I just worked that out because I realized that the only difference there is in the tenths and hundredths place. Let's move on to question. Alrighty, so for the B question it says, by adding or removing some sugar or oats to or from the bags, how can Emma and Ebo get the scales to balance? So in order for the scales to balance, both sides have to weigh the same. And I identified in my last answer that the side with the oats and the pears weighs 0.49 kilograms more. So what could I do? I could either take 0.49 kilograms away from the oat bag, Or I could add 0.49 kilograms of sugar to the sugar bag, and that way the sides would be equal, either at 3 kilograms or 3.49 kilograms. Let me write my answer and show you what I mean. All right, so here's my answer. I said, once this focuses, they can take 0.49 kilograms away from the oats bag so that both sides weigh 3 kilograms. Or they can add 0.49 kilograms to the sugar bag so that both sides weigh 3.49 kilograms. And then I drew a little illustration below to show what I meant. Here, it's like balancing number sentences. 3.49 minus 0.49 is equal to 3. And 3.49 is equal to 3 plus 0.49. So those are the ways that I can make the scales balance. All right, on to the Think Together portion. Question 1 on Think Together says, Emma weighs out some sugar from the 3 kilogram bag. How much sugar is left in the bag? And there it shows me a picture. So she had the 3 kilogram bag. She put 0.74 kilograms on one scale and 0.65 kilograms on the other scale. They also show me a bar model to help me understand what's happening. So the 0.74 kilograms plus 0.65 kilograms plus whatever is left in the bag now would add up to 3 kilograms because that's what she started with. So I need to work out what's left in the bag. All right, well, to me, the easiest way to work this out is to find the total that she's taken from the bag so far, and then if I subtract that from 3 kilograms, I'll get what's left in the bag. So 0.74 plus 0.65. 4 and 5 is 9, 7 and 6 is 13. Carry my 1. So far, she has weighed out 1.39 kilograms of sugar. That means whatever is left in the bag is 3 kilograms take away this. So if she started with 3 kilograms and she's weighed out a total of 1.39 kilograms, I need to find what's left. All right, let me steal. That turns to a 10 and eventually turns to a 9. We know the drill. 10 take away 9 is 1. 9 take away 3 is 6. 2 take away 1 is 1. So that means that right now left inside the bag is 1.61 kilograms. So that's my final answer. How could I check if I'm right? Well, remember the bar model showed that 0.74 plus 0.65 plus whatever is left in the bag should add up to 3. So when I add these together, I should get 3. You go ahead and check if I get 3. Now for question 2. It says a tablespoon holds 18.6 grams of flour. A teaspoon, which is a smaller spoon, holds 15.9 grams less flour than a tablespoon. What is the total mass of flour on the 2 spoons? Oh goodness, so they're trying to trick me here. See, I have to work out first how much a teaspoon can hold by subtracting from the tablespoon, and then I need to figure out what they hold all together. Okay, so let me think. The tablespoon holds 18.6 grams. That's the tablespoon. Here's the shorthand for tablespoon, TBS. Tablespoon. The teaspoon holds 15.9 grams less than this. So if I take away 15.9, my answer is going to be what a teaspoon holds, which we write as TSP, teaspoon. So let me subtract. Gotta steal, because there was more on the floor. 16 take away 9 leaves 7. 7 take away 5 leaves 2. 1 take away 1 leaves nothing. So what I've learned so far is that, as they told me at the beginning, a tablespoon holds 18.6 grams of flour, but a teaspoon can only hold 2.7. Now they've asked me for the total mass of flour on the 2 spoons. If I'm looking for a total, what do I need to do? I need to add. So now I'm going to add the tablespoon, which is 18.6 grams, and I'm going to add that to the teaspoon, which is only 2.7 grams. I got my information for the teaspoon over there. 6 plus 7 makes 13, carry my 1. 1 plus 8 plus 2 makes 11, carry my 1. 1 plus 1 makes 2. So in total, the 2 spoons can hold 21.3 grams of flour. There we have it. Right, on to the challenge. It says there, a street has 4 lampposts in a line. Jen measures the distances between some of the lampposts. Now, I've gone ahead and drawn a little diagram, and I'll explain it as we read through what Jen has said. She said the distance between the first and second lampposts is 5.85 meters. So as you can see in my little diagram, I've drawn my lamp posts. I have 1, 2, 3, and 4, just like she said there would be. And in between the first and the second, it's 5.85 meters, just like she said. Then she says in between the second and the third lamp posts, it is 6.189 meters. So I wrote that as well. Then she says, and you have to look at this carefully, the distance between the first and the fourth lamp posts is 3 times the distance between the first and the second, which was 5.85. So essentially she's told me that to get from 1 to 4, I have to do 5.85 meters 3 times. So that number sentence, 5.85 times 3. The question, though, isn't going to ask me what is the distance between the first and the fourth lamppost. They actually say at the bottom, what is the distance between the third and the fourth lampposts? That's why I have my question mark there. Now, what this question is really doing is asking us to do a couple of steps. First, we need to work out the total distance from 1 to 4, and then we need to find the difference here. Let me show this to you as a bar model. All right, so I've gone ahead and done my bar model. There we go, it's nice and focused now. So I've made it line up to my diagram above. So we can imagine that this top bar is the total distance from the first lamppost to the last one. And as she said, it's 5.85 times 3. Now underneath I can see my distances between the other lampposts. Between the first and the second lamppost, it's 5.85. Between the second and the third, it's 6.189. And between the third and the fourth is what we don't know yet. So what I'm going to do first is work out the total distance from 1 to 4. Now you'll notice in the textbook that Astrid said, I think I need to multiply decimals. But we haven't learned how to multiply decimals yet. Fortunately, Flo gave us a little hint. She said, I do not think you have to. I think you can add the number 3 times instead. So let's do that. We can do 5.85 plus 5.85 plus 5.85, and that's the same thing as multiplying it by 3. And that way we can find out what the total distance is. So let's stack it down here. Five plus 5 plus 5, 15. 3/8 is 24, so if I add 1, I get 25. Carry over my 2, 25. 5, 10, 15, 16, 17. All right, so that tells me then that the total distance between the first lamppost and the last one is 17.55 meters. Now that's great because now I know what to subtract from. This is my total up top, and if I take away these 2 baby numbers, I'll be left with this baby number. So I'm going to take these away all at once, and the way for me to do that is to add them together first. So when I add them up, I can then take them away from 17.55. All right, so let me add those 2 baby numbers together. 6.189. I'm going to fill this space with a 0. 0 plus 9, 9. 5 plus 8, 13. Carry my 1. 1 plus 8 plus 1 is 10. Carry my 1. 1 plus 5 plus 6 is 12. All right, so the distance from here to here, right here, is 12.039 meters. So I need to find what's left to get to 17.55. To find what's left to get there, let me subtract. This is quite a few steps in this problem. So I'll subtract from my total, and I'm taking away the distance that I already have. So 12.039 is what I know from here. Oh my goodness. You guys, you know I'm doing this with one hand, so you gotta forgive me. Here I notice there's nothing to subtract from. I just fill the space with a 0. There's nothing there, 0 is worth nothing. So now I can steal from here. Becomes a 4 and this becomes a 10. 10 take away 9 is 1. 4 take away 3 is 1. 5 take away 0 is 5. Put back my decimal point. 7 take away 2 is 5. And 1 take away 1 leaves nothing. So I figured it out. The distance from the third to the fourth lamppost is 5.511 meters. How can I check my answer to be absolutely certain that I'm correct? Well, I can add them all up. I can say, okay, is 5.85 plus 6.189 plus 5.511 meters, which would go here, does all of that add up to 17.55? If it does, then I know I'm correct. And I can double check it a little bit further by making sure that I worked this out correctly, that 5.85 3 times is 17.55. So problems like this, which you're going to be seeing in your workbook, they're not really hard. They're just a lot of steps. So I had to do quite a bit of work to find my answer, but it wasn't hard work. So you just need to take your time and be patient.
And now for your independent work. Today's work is a bit more challenging than yesterday because most of the problems are multi-step problems. Question 1 starts out pretty simply with just needing to find the total of 3 items. But then in question 2, you're going to notice it's asking for change. We know when we're finding change, we have to look for the difference, which means we subtract. But in this particular problem, before you can subtract, you have to do some addition. You have to find out his total first. This trend continues on the next 2 pages, where all the problems are multi-step problems. And for some of them, you're going to have to look closely at the information that's given to you. They're not giveaway problems. They're not super simple. They are meant to be challenging. So if at first something doesn't make sense to you and you say, I'm stumped, I want you to take a moment, look at it more carefully, and give it your best shot. I don't want you to be putting question marks on all of these. They are meant to challenge you. Give it your best go, and when you're done, send me pictures of your work. As always, stay safe, and I'll see you soon.